Alright. Section 5.1, we'll discuss the graph of y equals natural log of x. In this section, we'll focus on its inverse, which is e to the x. Right? E to the x and natural log of x are inverses of each other. Alright. So I don't understand why we just did that. So. Alright. Solve each of the following equations. So, remember, e to the x and natural log are inverses of each other. So we take the natural log of both sides. So natural log of e to the x plus, was that a plus 1? Alright, so remember they're inverses of each other, so they simply cancel each other out. So you got x plus 1 equals natural log of 7, so we just subtract 1 from that. So it's negative 1 plus the natural log of 7 equals x. And you get a decimal approximation for that. Just put that in the calculator. So that will be clear. Negative 1 plus the natural log of 7. And you get that. And that's 0.946. X is approximately 0.946. Alright. Here, remember, so you want to take e of both sides. Remember they cancel each other out. So they cancel. It's 2x minus 3 equals e to the 5th. So 2x equals e to the 5th plus 3. So x equals e to the 5th plus 3 over 2. Put that in the calculator. Oops. So I'm going to use the calc fraction button here. E to the 5th plus 3 over 2. And you got 75.77. So it's about 75.707. 707. Okay, pretend you can see that. Alright, going on. So here's some basic things. If you have e to the a times e to the b, it's equal to e to the a plus b. If you have a quotient, you subtract them. The domain of e is all real numbers. The range is 0 to infinity, not including 0. The function is continuous, increasing 1 to 1, just like natural log. And opposite of natural log is concave upward, right? Remember, it's an inverse. Take the limit as x goes to negative infinity, the limit is 0. X go to positive infinity, the limit is positive infinity. And here's the weird part, the derivative of e to the x is just e to the x. Right? And that's the general version. It's 156. Just go on to 157 because that part was pretty short. And I can't put my fingers on it. Alright, differentiate each of the following. So the derivative of that is e to the 2x minus 1. Right? So when you take the derivative of e to the x, you just get that back. The only thing you got to apply is the chain rule. Derivative of 2x minus 1 is 2. So it's better to write it like this. So there's no doubt where that 2 is. Okay. Here, that's a negative 1 over x, I think. No, it's a negative 3 over x. Okay, negative 3 over x. Alright, so it's e to the negative 3 x to the negative 1. Right? So take the derivative of that, it's going to be e, so just copy that, negative 3 over x, times the derivative of that, which will be 3 over x squared. Right? Subtract 1 from the exponent, right, and multiply by that old exponent. So that's why it's positive 3. You can rewrite this as 3e to the negative 3 over x squared. This derivative, find the extreme of x e to the x. So we need to find the derivative first. So keep the x constant, take the derivative of e to the x, which is e to the x, and then take the derivative of x and keep the e to the x constant. Set this equal to 0 and solve. Factor out e to the x, and I get x plus 1 equals 0. E to the x is never equal to 0. Remember, it's not even the range of e to the x. So this is only equal to 0 when x is negative 1. So what does that mean? So we make a sign trick for that. Negative 1. Plug in 0, and I get 1, right? This part is 0, but that's 1, so it's positive. Plug in negative 2. That's going to be negative 2, right? It's going to be negative 2 over e squared, right? It's e to the negative 2, so it's there. And then plus 1 over e second, right? So this becomes negative 1 over e to the second. So it's negative. So that is a minimum. Alright, so that means a minimum of x equals negative 1. We just plug in the negative 1 and we get negative 1 over e. Negative 1 over e. So what is 1 over e? Or e to the negative 1 rather. Either one. E to the negative 1 is probably easier. And it's 0.367. Alright. But it's negative with that. Okay. Is that right? If I plug in negative 1, oh, negative 1 there. So it's negative 1 e to the negative 1, which is negative 1 over e. And 1 over e is that. So it's opposite of that. So it's negative 0.367. So at negative 1, it's negative 0.367, just like here. Okay. And that's a minimum. Alright. As x goes to infinity, what the heck is this doing? Oh, it's doing something like this. Is it asked for any kind of well, it's 0 is 0, so it's going to do something like this, right? And e to the x, you just multiply by that, so it's still going up the same way e to the x does. And e to the x is going to 0, and it's probably going to overpower that, so it's going to be like that. I'm thinking there's a point of inflection here, though. Right? Let's do that for kicks. Let's find that point of inflection. So take the derivative again. So second derivative would be x e to the x plus e to the x plus e to the x. So it's x e to the x plus 2 e to the x. So e to the x, x plus 2. Right? If you set this equal to 0, we get x equals negative 2. And yeah, there's a sign change there, so there's a point of inflection at negative 2. Hey, that was pretty close. Alright. Okay, so that's that. Okay, and then this moves on to integration. Okay, so the only thing missing here is you need the derivative of the exponent, which is 3. So you're going to put the 3 in there, 3e to the 3x plus 1 dx. Compensate for that 3 by putting the third out here. So that just becomes 1/3 e to the 3x plus 1 plus a constant. Alright, so here, so you just need a derivative of negative x, what is that? X squared. So we need a derivative of negative x squared, which is negative 2x. So I'm going to take the 5 out, put the negative 2 there, x e to the negative x squared dx. So this is part of the original. 5 is part of the original. Negative 2 is the thing I'm putting in to make up for the fact that I need a derivative of negative x squared. So that's where the negative 2 comes from. Compensate for that negative 2 by putting negative 2 out here. So now it's negative 5 halves, this thing. This is the part that comes out, e to the negative x squared. The negative 2x is the derivative of negative x squared, so that gets absorbed. Okay, that's it. And that's it for that one.